Hi. We're going to look at a few questions today. These are our big questions that you should be able to answer by the end of this video. Number 1, what charge does a calcium ion have? 2, what charge does a chlorine ion have? And then 3, how many chlorine atoms and calcium atoms are needed to have a total charge of 0? So before we can answer this question, let's do a little bit of review. Remember that the number of valence electrons for a main group element is equal to its group number. So the group numbers are the ones that are across the top. Now in this picture I've cut out all of the transition metals so that we can just focus on the main group elements. So remember, this is group 1, 2, 13, 14, 15, 16, 17, 18, but 1A, 2A, 3A, 4A, blah, blah, blah. So your rows are the ones that go horizontally and the columns are the ones that go vertically. So remember, groups, periods. Groups, periods. So that's how you can remember that the groups are the vertical ones and the columns are the horizontal ones, or the groups are the vertical ones, the rows are the horizontal ones, the periods. If you're still trying to figure out the whole period and row thing, I know it's tough. I thought of this little thing, the fact that period, row, P, R, similar shape, group, column, GC, similar shape. Maybe that would be helpful. I don't know. I think that probably group, period is your best bet to remember the connection. Okay. The other thing that I had you guys look at in one of our videos was the Octet Rule, but I didn't go into a whole lot of detail about it. I'm going to explain the purpose of it now. So atoms have two goals in life, two primary goals. Goal number 1, above all else, they want to have a full valence shell. And that means to have this many, 8 valence electrons, just in the outer shell. And they also want to be neutral, but being neutral is kind of secondary. Being neutral means equal numbers of protons and electrons, so equal number of positively charged particles and negatively charged particles. So that means that they have a total charge of 0. There are some elements already that do this, and those are the noble gases. Remember the noble gases, the little hoity-toity nobility ones? They all have full valence shells. They all have 8 valence electrons. Then there's helium that's weird. It only has one energy level and only 2 fit in that first one anyway because it's a little smaller. So this one is actually satisfied, stable, and totally fine with just the 2 because it only has 1 shell. Once we get into the second level, then they have to have 8 and so forth. And then look how argon is happy with 8 in that third level, but then krypton, it can actually fit 18 electrons in that third shell because it has a 4th shell. So the valence third can only have more than 8 if there is a 4th shell. So your valence third, if it's a valence shell, if it's the outer shell, the third one, it has to be 8. That's the maximum. Alrighty. Now, back over here, looking at the rest of these elements, all of these do not have 8 valence electrons. Or in hydrogen's case, does not have 2 valence electrons. So they're not full. They want to be like noble gases. They want to have what's called noble gas configuration. And so hydrogen is the easiest thing for it to do to look like helium is to just gain 1 electron. So it will likely gain 1 electron, and if it gains something that's negative, is it going to have a positive or a negative charge? Well, it's going to have a negative charge. It would have a 1- charge. That's the way that we describe it. We don't say 1 negative charge, they actually say 1-. And then for lithium, lithium wants to do something similar. It could just, actually no, I back up. Lithium doesn't want to do that. It doesn't want to just gain 1 because it already has a full first layer. It has a second layer here. It needs to have 8 in that one. So it could gain 8 electrons and then have a similar look to neon, but that's a lot of electrons to gain. It would be a lot easier for it to just lose that one. So that's what it tends to do, is lose 1 electron. So if it's losing 1 electron, but it still has 3 protons and 2 electrons, then that means it's going to have 1 extra proton that's not balanced by a negatively charged electron. So it's going to have a 1+ charge. Then barium, being an element that has 2 valence electrons, it's still easier to get rid of the 2 rather than gain 6 so that it could have 8. So it's going to get rid of the 2 and have a helium-like electron configuration. So it'll get rid of those 2. So it starts out with 4 protons, 4 electrons, gets rid of 2, still has 4 protons, but only 2 electrons now. So that means it has a +2 charge. Boron then would have a +3 charge. Then we get to carbon. Lose 4, gain 4. Lose 4, gain. There's not one that's easier than the other. Carbon actually will do either. It does both all the time. And most of the time, carbon will actually just bond to itself and just make these big long chains of carbon. So that's kind of a weird one, and that happens specifically because it has these 4 valence electrons. It's kind of a weird one, kind of special. So it actually is what allows proteins to get made that make up you and make up cells and everything. So that's actually really helpful, and our NOVA talks about that too, that documentary, Hunting the Elements. It's really neat. Anyway, then we get over here to nitrogen. Now nitrogen has 5 valence electrons, so it could lose those 5 and look like helium, or it could just gain 3 and look like neon. Well, what's easier? Gaining the 3. So it starts out with 7 protons, 7 electrons. It gains 3 more electrons now, 10 electrons, and only 7 protons. So it has a -3 charge. Whereas oxygen is going to gain 2 electrons, -2 charge. Fluorine, gain 1 electron, -1 charge. So then you can see how the trend would continue through the rest of those. Okay, now when you've got the plus charges and the minus charges, we actually have specific names for those. For cations describe the positively charged ions. You get positive, get it? Pause, like cats have paws. Actually, the way that I remember it is the word cation has this T. The T, I think of a plus sign, so that's how I remember it. Then the other type are the anions. Anti, negative, that kind of thing. I also think, the word anion is almost the word onion. If we change that to an O, it would be onion. And when you cut onions, you cry, so it's negative. Maybe I'm going too far, I don't know. But that's how I remember cations plus anions, negative. Okay, so a little close-up example of that, looking at sodium. Here's sodium with its initially 11 protons, 11 electrons. It's got this 1 electron in its outer shell. So that one, it doesn't want it. It wants to get rid of it so that it can have the same electron configuration as neon and just have 8 in its valence electron shell. And then it looks like neon right here. So now this is a sodium ion as opposed to a sodium atom. And it has a full outer shell, and it loses 1 electron. Then we've got the negatively charged ions, the anions. Those want to gain electrons. So you kind of see how, oh, hey, look, I want to lose 1, you want to gain 1. That works out really nicely. So what happens is sodium gives up an electron to chlorine. Now both of them have full valence shells, but then we see, hey, sodium is a +1 ion, chlorine is a -1 ion, +1, -1. That second thing, first they wanted to have full valence shells. They got that now. The second thing that they wanted was to be neutral. So if they bond together, they can overall, as a compound, be neutral. And that's why sodium and chlorine like to bond. And that's why we have delicious salt. Okay, let's take a broader look at all of the elements and general trends about how cations and anions are formed over all the different elements. First, let's look at metals. So zooming in on this is just the main group of elements. So just the A group, so 1, 2, 13, 14, blah, blah, blah. Notice that most of the metals are in groups 1, 2, and 3. There are some over here as well that are a little weirder. But most of them are in 1, 2, and 3. And remember, lanthanides and actinides are actually all technically part of group 3. Group 13. Technically in that one, but not really. Anyway, looking at these, we know that these guys, 1, 2, and 3, it's easier for them to lose 1, 2, or 3 electrons than to gain 7, 6, or 5 electrons. So these guys are generally going to become cations. Then when we look at the nonmetals, most of our nonmetals are over here in the 5, 6, and 7 columns. It's easier for them to gain 3, 2, or 1 electrons rather than lose 7, 6, or 5 electrons. So they're going to tend, because they're gaining electrons, they're going to tend to be the anions. So metals form cations, nonmetals form anions. Alrighty, now metalloids, those guys in the center. Notice they're kind of all over the place. Like here's boron over here in group 13. Then you've got silicon and germanium in 14, arsenic, and these guys are 15, 16. So it depends kind of on their column. And then remember these guys in 14, because they're 4 exactly, it doesn't matter if they gain 4 or lose 4. They can go either way. So they're fun and in the middle, and we don't know what they're going to do. All right, now coming back to these 3 big questions that we had, the charge of a calcium ion, charge of a chlorine ion, and then how many of each do we need to get a charge of 0? Now that you've got the skills here to figure out what charge an ion is going to be, what charge an atom is going to make, I want you to look at calcium and chlorine and see if you can figure that out. All right, now what's going to happen here is an ionic bond. So an ionic bond is when ions combine chemically. Combine chemically means that their atoms actually join up to form a compound with a neutral charge. So calcium has 2 valence electrons. It's going to get rid of both of them. Send one to this chlorine and one to this chlorine. So because it's losing 2 electrons, it's going to have 2 protons that don't have an electron to balance it. So it's going to have a 2+ charge. Each of these chlorines gaining an extra electron, they'll each have a 1- charge, 1- and 1-. So you end up with 1 calcium being 2+ and 2 chlorines being 1-. So you need 1 calcium and 2 chlorines to equal out to a total charge of 0 and to be neutral. And the chemical formula for this substance is CaCl2. This is calcium chloride. And that Ca stands for 1 calcium. And then having that 2 there, that tells us that there's 2 chlorine atoms, kind of like H2O. There's 2 hydrogens, 1 oxygen. All right, so that is your crash course in ions and ionic bonding. See you next class. How do I stop this crazy thing? Seriously, how do I stop? Oh, there it is.